In video 6, 7 and 8, we are looking at the second part of our lecture this week, which is examining credit risk. So what is credit risk? Well, credit analysis is really concerned with three things. So what is the probability of default? So how likely is it that a company will default on its debt obligations? Because remember that a bond is simply a contract, a promise to pay. So how likely is it that they're going to break that promise to pay? If they do suffer a default, what's our expected recovery rate? So how much money will we get back if the company goes into default? And then the third element is, what's the appropriate price for a bond or the yield to compensate for that level of risk? So there's really three types of credit risk. So we have the default risk, the risk that the issuer will fail to meet its obligations to make timely payments of interest and principal when they promise to have paid it. We've got credit spread risk, the risk that the spread that the market demands for any issue will increase or widen, resulting in inferior performance of an issue relative to another issue. So if a bond has a particular risk profile, in some periods the market may be willing to accept more risk and not be compensated as much of a premium. And so you'll potentially often see this in bull markets when the market is very optimistic and the risk appetite for people is high. You will often see that credit spreads can narrow. Whereas often when we're in a correction, everyone flees to safety. And so then credit issues which have more risk, even though they may not have become more risky per se, the fact that people no longer want to hold risky assets, that yield that's demanded for a particular level of risk may increase. And hence, if that credit spread increases, that will then mean that the price for those bonds will fall. And then the third element is a downgrade risk. So that's the risk that the issue, the bonds that we've invested in, will be downgraded, and that will result obviously in an increase in the credit spread. So obviously, if the credit quality of the firm is no longer as high as it once was, and hence it's more risky, we will demand a higher level of credit spread, more of a yield to compensate for that risk. So there's two main standard techniques for measuring default risk. The first is an accounting approach, which involves the analysis of historical and projected financial statement items with reference to benchmarks shown to be associated with historical default rates. And that's primarily the approach used by most of the rating agencies, such as S&P, Standard & Poor's, Moody's or Fitch. A second approach is called a market-based approach, which involves estimation of expected asset returns and the volatility of those returns in order to model the probability that asset values fall below the value of the debt. And this was introduced by Merton in his 1974 paper. And this is the business model of Moody's KMV division. So the Merton distance to default model is basically provided by these formulas. So the distance to default is DD, and that's basically the log of the value of the firm's assets divided by the face value of the debt, plus the expected return on the firm's asset minus a half of the standard deviation in these assets' returns squared, so the variance of that, and all of that multiplied by the time to maturity. We then divide the numerator by the denominator, where the denominator is the standard deviation of the asset's returns, multiplied by the square root of the time to maturity. Now, once we've calculated that distance to default, we can then work out an expected default frequency by looking at the normal distribution of the negative of the distance to default. So let's look at an example. Let's suppose we have assets that are valued at $100. We have $50 of debt. It's repayable in 2 years' time. We have an expected return on assets of 10%, and the standard deviation in the return of those assets is 30%. Then we can work out that the theoretical distance to default is 1.893. And so then if we look at the distribution, we can see that there's a probability of default of 2.9%. So the advantage of this technique is that it provides a substantially more timely measure of default compared to the rating agencies, when the rating agencies have to wait for accounting numbers to reflect new information, whereas this measure can be constantly updated with updated values. The limitation of this model is that the theoretical probabilities of default are too low for investment grade bonds relative to the default rates that we've actually observed in practice over time in history. So empirically, this has been shown that the model is too conservative. It doesn't show sufficient rates of default. So in practice, we need to map the distance to default estimate onto empirical default rates to come up with a better estimate of the probability to default. Even if the probability of default is not computed, the distance to default can also be used as a reasonable technique for ranking the credit quality of firms, just simply using that distance to default, even though it doesn't give you a completely accurate estimate of the default rate. In our next video, we'll be looking at credit risk and the rating agencies.